All right, so next lecture here. Something else that we should be checking out here. We're going to go back to writing some valid TypeScript here. So we can just do function add, and this will be x number, y number, right? And I need to finish this off here. And what will this do? This will return x plus y, right? Pretty straightforward. I think we can even do, actually I haven't really written things this way, but we should be able to do this. Yep. And so this is going to say it's expecting a number back as well, right? So this is just being super explicit. Add is going to return a number, and it has to take two numbers, right? And so if I were to say, console.log add 5 apples, right? Immediately mad, it says you can't do that. It's a string. You can't get that figured out, right? So there we go. So that's already something, and it also yells about not having enough parameters or arguments, whereas JavaScript will not worry about that, so on and so forth. But let's go ahead and just pass in 7. And what I want to do is I'm going to use the TSC command, and this is going to be actually the TypeScript compiler is what that stands for. And we're going to say index.ts, and I believe, if I'm right, give me a second. Cool, it worked. All right, great. So this here, tsc index.ts, and then you can add this flag out file hello.js. I can also just do tsc index.ts, and that will put it into an index.js. It will just be an immediate parallel. You can see that the CPU is working pretty hard here to think about this, because they don't give you a lot of power when you do this. But now we have an index.js. I'm just going to delete that straight out because I want to look at my hello.js. So we have this, and you can see that we've gotten this here. Now notice that all of the TypeScript specifics have been stripped away, right? That's all been taken away. So this is what I mean by TypeScript is for developers. The only reason this is here to tell you that this is not okay is to warn you that that stuff's not acceptable. And what TypeScript will do is it will run through this and remove all of this stuff. So it will be checking for you while you're developing. But when you say compile, it will get rid of all of the TypeScripty stuff and return to just X, Y, add 5 and 7, and it will just return to plain old JavaScript, which is great. You can do this for huge files, right? Entire applications, it will do this for you, which is really great. So that's kind of the idea here. I just wanted to show you that you can use TSC to do that. That is actually one of the things that is happening when you are using all of this stuff. I believe it's somewhere in here that it's saying use TSC to go ahead and do that and where to put it in and out. But these are just kind of rules. All these flags and stuff you can have for your TSC. I actually Googled it real quick and just looked at the documentation for the CLI. All of this stuff is stuff that you can basically have happen, and you just pass it into your tsconfig, right? So your tsconfig reference, what's all in your tsconfig, right? And you can have all this other stuff, watch options, etc., which is actually, that allows it to actively be watching, so you don't have to compile it every time. So it will just constantly, and you'll see this when we get to React and Vue, should you be taking those with me. But almost every YouTube tutorial, almost anybody that's using TypeScript for React or Vue is going to be using this active watch thing, which is going to be checking on it. Cool stuff. So that's all that's going on in there, and that way you don't have to write all these flags. There's a lot of flags you can add, and that's not necessarily what we want to do. So we're going to come back to our index.ts, and I'm going to say let ein number equals 1, let zwei string equals hello, and we're going to say let dry boolean, and this is going to be an array. So this will be actually an array of booleans is what's going on here, right? And so we're going to have true and false, and so that's what we're doing here, right? And if I were to pass in, like the string false, suddenly we'd have a problem, right? Because boolean will only accept booleans, and this is going to be an array of them. So that's how you would array slightly more complex, like mixed primitives. Actually, it's not really a primitive. An array is not a primitive. It's actually a more complicated thing. But you have false here. Same thing here. We could have eins, zwei, drei, vier. Let vir number, and we'd have an array equals, and you'd have 1, 2, 3, 3, etc. Right? But if you try to add false here, then it will not be very happy with you. Okay, that's not a number. That's not acceptable. So that's how we're doing that there. And again, you say, oh, well, okay, so that's how you do arrays. What about if I want to do an object? Once again, you have to write an interface for your object. Okay, and just be really clear what you're expecting for your object, what those shapes and sizes and types are, because objects are where a lot of undefined stuff comes up, as we saw with our foobar object earlier. So, or our thing with the foo value there, okay? So, if I were to do 3 plus 1 like this, JavaScript will allow this. And actually, if I copy this and put this into my little Google console, it goes to 31. Now, what on earth is going on here? Well, it assumes that you're trying to add these two together, and it's obviously taking this plus sign as a concatenation, right? Where you can say, you know, apples plus oranges, right? You get apples and oranges, right? But it's trying to do the same kind of thing here, where it says, you know what, a string is actually a very flexible data type, right? Because again, you can include numbers, you can include characters, you can include a lot of things inside of a string. You can even have something like, you know, 1, 2, 3, and that counts as a string, right? So strings can kind of just be put as bookmark or like bookends for a lot of different stuff. And so what JavaScript is going to do for us when we do 3 plus 1 is it's going to assume what we're doing is we're going to take 3.toString plus 1.toString. And lo and behold, we get 31. So this is what JavaScript's trying to do, to try and just be as friendly as possible and not hurt our feelings. But this is probably not what we actually wanted when we did this. And so this can be really tricky with how this goes. And as a result, it's actually very good that TypeScript checks those things. Again, I hope that by this point in time, I've made a pretty good case for TypeScript. And okay, some will criticize me and say, Brandon, you shouldn't be kind of preaching TypeScript. You should probably just be saying these are the tools and you can use them as you please. But I don't know. This makes sense to me. It's very helpful. It's much clearer. And you're gonna have headaches. Most of the apps we're writing are gonna be in JavaScript, but we're gonna be able to see that there's headaches with those. We do a pretty sizable React app with TypeScript, and that'll be very kind of enlightening as well. But anyways, yeah. So one more thing we're going to look at here, and then I think we have some more, I guess, theoretical aspects that we'll be looking through. Actually, we're going to look at the data types, so that'll actually be really valuable, and messing around with some other code in a bit. So, but yeah, last thing I guess for this. So we looked at those. You know what? No, I'm going to skip that. We're going to launch right into the data types because those are more important, and this is just more examples of the same thing. And I think my students are probably reasonably clever, and they don't need just heaps of examples of things. We should probably just get right into it. So that's what we're going to do. Let's go ahead and get started off with, and we've seen a function, right? So we've seen function square of, and we pass in n, and n is going to be a number. And what we're going to do with this is we're going to return n times n, and that'll be fine. Okay, so that's all groovy. We can do square of 2, and that will end up resulting in 4 ultimately, right? So again, that's how you pass a parameter data type there. A few different data types here. We're going to take some notes because these are going to be important. And again, we've kind of been looking at this whole time, but this is going to be where some of the stuff I've been talking about for a while kind of meets. Well, this is going to be things that we're just going to need to remember and be able to use repeatedly. First one is we have the any data type. This can do any data type, but it's probably an indication that you're not using the tools right. And that's not always necessarily the case. It's just kind of like hey, like you really need to be sure that you're expecting an any here. I believe I do use one of them in the in the React app, but part of it too is that we're getting data from someplace else, and we're not necessarily sure what that's going to look like until it's in our application. And so that's part of why you would be able to use that, especially if you're just not sure what's coming back. Again, with JSON, you can get numbers or strings. So you could say either one of those, but it also could be an object. We don't know what the interface for that object is going to be, et cetera, et cetera. So that's going to be kind of the only time you're really going to want to be using the any. Unknown, this one's new to us. And so these TypeScript, TS won't let you, won't let you use these types until you check what it is. I have not actually seen this in the wild, so I wouldn't be too concerned about it. And also, since we're coming from JavaScript, it's going to be pretty weird to be using this. But it basically requires you to use a type of to check. Again, it's an unknown data type. What is it? I don't know. So you use type of to ensure that it exists, that it is a certain thing. You say, oh, it's type unknown, but I think it's a string. So you have to use type of after that to check that it's a string before you can use that in your code. I suppose we could have used an unknown instead of any for our React app, but we'll get there. Boolean, this shouldn't be complicated, right? So we can also do type literals with Booleans. Type literals, and this is going to be a type that supports one value and nothing else. So we can actually do this where we say let a true equals true, right? And this means that a can only be this thing, right? We can also do this with I think with numbers. Let num5 equals 5, right? And that will also allow that to work, and so that will ensure that num is only going to ever be 5. Of course, we also have const, which will kind of also ensure this. But again, if we're passing data into things and we want to use them as, like, again, this could be a more complicated thing than 5, right? Obviously, it's a little bit silly to do it at this level, but you can do this with a full object, right? And that way, you'd actually be able to ensure that the object is what you're expecting. Anyways, so that's what type literals are. We also have our number. Pretty straightforward. So check this out too, right? We're going to do console.log type of, and we're going to say num1 here. I have not declared what num1 is. So we're going to say num1, we're going to let num1 equals 20. And then we're going to say let num2, or we're going to say const num2 equals 20. I'm going to do this. And I think I used type of wrong. Let me double check that documentation. Oh, okay, it's just inside of a, all right, neat. So, I need a space there. I guess this is lowercase. Type of num1, and then we're going to copy the whole thing. We're going to do this again with num2. It's a weird way of calling a function. I don't know what JavaScript was thinking, but I should be able to run this, and we get back. Oh, we get back two numbers. That's interesting. That is not what my notes had, because I had the notes that would say this would actually turn into the type would end up being 20. Would end up being 20, similar to this. Might be type of not being able to return what we're actually looking at there, but essentially, in theory, what you can think of is this as the type is now 20. It's just, I don't think JavaScript actually has that as an option. Yeah, there we go. Actually, that's it right there. So here we have that it ends up being a number. There we go. That's what I was looking for. So num1, let num1 is number, and const num2 ends up being 20. So there we go. That's what I was looking for. It's just that, again, JavaScript doesn't have the type of 20. That's not a data type that you can pass in. We have big int. This is for like huge numbers. Again, our computers can only process certain numbers of a certain size of data at a time. It does that very quickly and does lots of them per second. But that's actually counts to your clock. So if you say, oh, that we're overclocking something, that means that you're actually passing more things in than the thing can handle at once. Anyways, I digress into computer science. But big int is going to be a number that's larger than our thing can handle. There's extra rules for how big int actually works. But we're not going to use these. We don't really use these for now. We've got a string. I think it's pretty straightforward. This is just characters. An array of characters. And then we're going to have, because that's what a string is under the hood, but we knew that already. Symbol is another weird one. This is totally unique. unique, even if a equals symbol 1, this is actually a class type here, and b equals symbol 1, a equals b will evaluate to false, right? So symbols here, again, this is another thing that's coming from kind of deeper into type theory and set theory. We're not going to worry about it too much. If you're using symbols and also enums in your code, it's probably not a great idea. There are times where that's appropriate, but not at the junior dev level, so we're not going to worry about it. We have objects. We've been over this a whole bunch. Objects should be inferred frequently. So objects should be inferred, which is what we saw earlier, where you can just create an object, right? Const thing equals, foo 5, bar 5, etc. So this is fine. You don't have to actually give it those types. It doesn't need a interface for this, and so we could infer it. Otherwise, make a interface. But that interface, then, whatever object you have, you're going to have to make an interface for every type of value inside of our object. Objects tend to be vague. So TS, TypeScript will try to play security. And it seeks specifics. And objects are still mutable. Objects are still mutable. So we can still add things to our objects, create new stuff. But again, if you have an interface for it, there's going to be some extra steps for that one. So we can also have let AA, since we already used A earlier, equal. This is going to be actually not equal. We're going to have B number. And so none of this is instantiated yet, right? I can't be like, console log AA.b because AA hasn't been instantiated yet. It hasn't been given any data. So it's used before being assigned. And that's what we mean there. So that's going to be mad there. But essentially what we're saying here is let AA be an object that contains a number B, right? So that's essentially how we can read this. That's how we can think about it. And again, this is going to be how we kind of process this stuff. How do we make an AA? Not like this, because it will be mad. It says, hey, you have to give me a number. There's no B here, right? Property B is missing in type thing, but we're in type object, but it's required. So it's not here, but it is required. So how would we fix this? We could just say, B1. And now everybody's groovy. Now everything's cool and everyone's happy, right? What if I were to add C2? Again, this is part of why sometimes with our objects, C does not exist in type B number. So again, it's taking this and saying this is gospel. This is all that we can work off of here. And you've given me more stuff than what you told me I was allowed to have. And so there's other ways of adding things in there, making them mutable, but that's part of why objects should be inferred generally, unless we are absolutely confident that that's the only size and shape that we want that thing to be. So especially if you're going to reuse classes, right, or reuse objects repeatedly, you want to write that shape out for them and kind of stick with that. Let's play around with this. So we're going to say type age equals a number, right? So you can just say we've just created a type, right? Age is of type number, but age is a specific thing. So you say type person, and we can make this more complicated, right? We say name string and age, and you say, oh, age should be a number. Well, what if we just say this instead? You can. You have created a new data type, and TypeScript will accept this from there. Now, it's obviously just piping number to here, but this is valid TypeScript. We can say let age equals 55. So that's nice. And then we can say let driver be a person. And we're going to set that equal to, because again, we've defined what a person is. And so now it's going to be mad because it doesn't have the person's name or age in here. So we can say the person here. So we're going to have name will be James May. And the age will be age. and this is valid, right? Because it's going to be pulling this value from here and piping number in through age all the way through here, etc. Actually, it doesn't pipe through here. This actually ends up being kind of united between this age declaration and the fact that this age is that valid age type. Cool. Let's try some other stuff. So we can't declare a type twice. Can't declare a type twice. So I could say, you know, type color equals red. And again, this would be a very specific type declaration, right? This would be similar to up earlier where we said we had type literals. So this is going to be the color is of the type string red. But I can't redeclare that type color equals blue. And it's going to be all mad and say, you can't do that twice, bah, right? Duplicate identifier color. Great. We learn by throwing errors. Cool. So moving on, we're going to look at unions here, where there can be something or it could be something else. And it could also be something and something else. So we can have, let's check this out, how this works, right? So we're going to say type cat equals, and we have an object of name string. Purrs will be Boolean, okay, because it's a cat. Maybe it purrs, maybe it doesn't. Maybe it just wants to hurt your feelings. We're going to have type dog equals, we have name string, barks, Boolean, and wags will also be a Boolean, right? So we're expecting some information. We can have type cat or dog or both equals cat or dog, right? Or it could also, I guess, be both. We can also have type cat and dog equals cat and dog. And where on earth are we going to end up using this stuff? Well, let's do some examples here. Oh, actually, did I not actually put anything in here for the rest of this? Interesting. Give me a second. All right, cool. Got better examples. All right. So from here, we've got these different type options, right? And you're like, what could these be, right? What would this actually look like? This becomes kind of some weird stuff. So we can say let rex equals, and we can put in name will be rex, barks will be true. Oops, true. That would have been interesting. And wags will also be true, right? Good dog. Okay. And this right now is kind of its own thing, right? So it's just saying these are inferred types, right? String, Boolean, and Boolean. What if we were to say this has to be a dog, right? And because this lines up with what we've given, right? String, Boolean, Boolean, same thing will happen here. And so as a dog type, we get string, Boolean, Boolean, and that's, lo and behold, what we get, right? What if we said cat or dog, right? Let's just try this one. Where it could be a cat or a dog. Dog or both, right? And so this one could be, again, from this, it could be a cat or a dog. And in this case, because it is a dog type, then this ends up being fine, right? We see purrs, false, right? And this is actually going to import all of these options as well. So you're going to have a name string either way. But then it's also going to unite these together. And so this is where I think we've seen this in, I swear I saw this in high school algebra. But you're going to basically be able to add the purrs attribute to this, or actually, I mean, it's going to just combine the two together. And so now we have all of those. So that is fine. But we're going to leave this at dog for now. Some other examples, because we want to keep our notes accurate. We say, let confused be cat and dog, right? And in this case, we're going to have name is going to be Blex, because our cat's name is going to be Bonkers. Barks is going to be true, and wags is going to be true, and lo and behold, purrs will also be true, right? So we've got our poor cat and dog thing that is both, and it can both purr and bark. And we can say let bonkers be cat or dog or both. And this one we can have name will be bonkers, and pers will be true. So, right, so then we've got this cat or dog thing, and now we have kind of those options. So you might be saying, like, okay, this is kind of ridiculous, right? When are we going to make a weird mad scientist cat dog? Well, so out in the wild, it will look more like this, right? So we can say function true or null. We're going to pass in is true Boolean. And so now we have our function here. If is true, then return true. Oops, true. And Replit was taking a little nap there. And otherwise, we're going to return null, right? So what's the type value of the return of this function, right? Let's go back to mine. What is the type value of the return, right? So we can actually write this right here. And this will end up being, this needs to be Boolean or null. Boolean or null, right? And so that's going to be, actually we could even do an even more strict thing here. It'll either be true or null as a return, but this is a union, right? This is what that is it's anything that's associated with this data type or anything that's associated with this data type. Those are our options for what we can return. Obviously trying to do true and null gets a little bit wonky here, but you can see kind of basically how that will end up working. So that's kind of an intro to TypeScript. That's basically what I have here. So about 45 minutes to hours worth of lecture here. But yeah, that's basically kind of intro to TypeScript. We're going to see a lot more of this stuff in the future. I just wanted to kind of allow kind of the chance to see some of these things and get a little bit more familiar with what TypeScript is, how it works, and some of the theory involved here, so that once we get to bigger applications, then we can do that. Again, part of the importance of TypeScript is often scalability. And so then the reason for this is, again, you have a massive app, you have thousands of lines of code, and it's all JavaScript, and there's an error in there, there's something's returning undefined, but you don't know where that is. TypeScript will tell you right away. It will say, this is not what I expected to be handed, and there's a problem now. And so this is basically enforced pipelining, right? So if you have data moving through your app or whatever, this is going to make sure that the data that comes from one place and goes to another is of the right type, so that you don't end up with these odd errors with not a number or undefined or null kinds of values. It makes sure that the stuff makes it all the way through the pipeline as what we expect. And that's really good. And it's also noteworthy that most backend languages, so whether that is C, C++, Go, Rust, Zig, all of these languages have types. And they're going to enforce those types, and because we have to, with C++, it's the exact same kind of thing. Actually, JavaScript writes kind of similar to C++ in a lot of ways, but actually it's C was first, and then C++ and Java, and then JavaScript writes a lot like Java, but it's not Java, so please don't call JavaScript Java. People will do that all the time, but don't do that. So anyways, that's part of why this is the way it is. They just said, hey, wait a second, why does JavaScript get away with just like not paying attention to this stuff? We're writing massive applications with JavaScript, and we need to have those type checking to ensure that things work. For smaller applications, right, like probably less than 2,000-3,000 lines of code, you really don't have to do that. It's not that big of a deal. But again, you get some massive, I mean, think about how big like Facebook is, or if you're writing front ends for video games with JavaScript, right, you're probably going to want to have those types available to you, so that then you don't have to worry about that anymore. Anyways, welcome to TypeScript. I'm a big fan. It's hard, it's annoying, but it really does make our apps work right the first time. Once we manage to get through the weeds of all the errors out front. And it also helps make you a better programmer, because it will help you think about these kinds of things and kind of plan ahead for what's my app going to do, what is this function going to actually happen. It helps you think about edge cases, right? We talk about like when you're doing interviews and code wars or leak code type stuff. It helps you think about, wait a second, what am I actually expecting here, and what am I going to do with it? How do I change that data type into something that's usable for what I need? Those kinds of things. So that's pretty much what we have here. Hope you had fun, and I'll see you in the next module.